So thank you all for coming. This is normally I like to do a session where like we talk about basically code something. I have like a really great talk on Spring AI, which I think Jonathan said that the community here did not want because you've done a lot of AI, which is fine. And then perf testing, which I get down and dirty and talk about low-level JVM internals. But you guys wanted this, so I'm happy to talk about this. This is actually a great presentation. Gave it. Surprisingly, the Montreal people also picked the same one, but that's okay. So my name is Pratik Patel. I think I already mentioned that I'm based out of Atlanta, which is in the southeast US. You may have read one of the books I've written over time, and I lead the developer relations team at Azul Systems. Now, how many people have heard of Azul before? Okay, so it's about half. So what Azul does is we make Java virtual machines. We're a Java-only company. That's all we do is we work in the JVM. And we have two builds of the JVM. We have a free one that's open source, always will be free. It's our build of OpenJDK called Zulu. It gets 200 million downloads a year. And then we also have a high performance VM called Azul Prime, which lots and lots of people use. For example, do you have Netflix in this country? I'm just joking. Of course you have it here, right? So Netflix is one of our big customers. There's a smartphone manufacturer that probably a lot of people in this room have their phone in their pocket, i.e. Apple. They're one of our big customers. Anyways, a lot of these folks use our high performance VM for various different things. And then we came out with something new about 18 months ago, which is called Code Inventory. And what this allows you to do is allows you to see what code you're running in production, and from that you can derive what code you're not running in production. So what do you do with code that you're not running in production? This is not a trick question. The trick questions come like, you can just shout it out. We're not formal here. Delete it. That's close. You delete the F out of it, I think is the best way to put it, right? And the reason why you delete code that you don't have, how many like newer junior developers, students do we have in the room? So a few, okay. So for those of you who are newer developers, the reason why you get rid of code that you don't use is it's a great way to very quickly reduce something called technical debt, right? And the problem with having tech debt is when I think you just mentioned, for example, like the new version of Spring 4 is coming out. And eventually you will need to migrate to it, right? And if you have all this code you're not using, then you have to migrate all that code you're not using also. And that's called technical debt because you're just carrying around all this baggage that you don't need and it just weighs you down, right? That's why it's called debt. Code Inventory allows you to find that code that you're not using, and it allows you to delete it in a safe way. It integrates with something called Open Rewrite. Are folks familiar with what Open Rewrite is? Right. So for those of you who aren't, Open Rewrite is a automated code refactoring tool. And so we have a recipe for that you can take our data, you take our recipe, you plug it into Open Rewrite, and it will help you safely and in a staged way with the process delete that code. So anyways, if you're interested in that, come and talk to me or hit me up on LinkedIn. All right, so that's enough of the product stuff. I already talked about Prime, how it's super fast. For example, if you run how many people run Kafka or any other big data platforms, right? So if you're using this, one of our customers who was just running their standard Java app with our high performance VM called Prime or Zing, they were like, oh, let's try this on Kafka. And they discovered that just by switching out from OpenJDK to Prime, Kafka ran 40% faster, i.e. they were able to push 40% more load through it. Or what they actually ended up doing was taking 100 servers that were running Kafka nodes and shrinking it down to 60. So they saved a bunch of money on their cloud bill. And if you deploy onto the cloud, you are probably familiar with the fact that it is not cheap. It is super expensive. So, and that's what I spend a lot of my time doing. It's helping people with performance issues, and then or helping them reduce the number of servers that they're running so that they save money and they don't pay as much money to Amazon or GCP or Azure or whatever they're using. Anyways, enough of that. We don't have raffle today. Okay, so with that said, let's dive into the presentation. Now, this is a fairly short presentation, so if you have any questions or if you have comments or you're like, wow, this is completely wrong, I don't mind you shouting out. Again, this is not formal, so we're in a pub, for God's sakes, okay? So if you have any questions or comments, please shout them out at any time. You will not offend me and you will not throw me off. I may retort your comment, but that's a different story, okay? So, first question that we want to ask is, are software architects also programmers? So before we answer this question, how many people in here are architects or have been software architects before? Just out of curiosity. Okay, so a few people. And everyone has probably worked with the software architect in this room, right? Because every large company tends to have software architects, even medium-sized companies. If you work at a startup, I used to work at a startup. After I worked at a large company, there was no software architect because there were 5 people on the dev team. So, not every company has one, but software architecture was still important, even at a small company. And I did most of that work, even though I was the senior developer, or as I like to call myself at the startup, a senior developer. So that's always fun. But the answer to this question, are software architects also programmers? The answer is that it depends on your company. Okay, so again, if you're at a big company, there's usually a formalized role called software architecture, and even at medium-sized and other companies. But it also depends on your role. So there are some companies which don't have explicit software architects. Someone who's a principal engineer may be doing the job function of a software architect also. You probably have seen that at the places that you worked at, right? Or a place that you may have worked at in the past. And then the final thing is also depends on you. A lot of people like to stay more on the coding side and less on the kind of system design side. We'll define what a software architect is. I think that's useful to kind of ground this discussion on code quality from a software architect's point of view, because the definition of a software architect depends from company to company quite a bit. Okay, so let's talk about that right now. Right? What are some of the things that a software architect actually does? So one of the main things that they do is software design and architecture, right? So this is high-level systems design, and it can include everything from, how are we going to build stuff? Are we going to use monoliths or microservices or somewhere in between, right? Or it could be other things like, if we deploy to the cloud, there's even specific subgenres of architect, as you can imagine, like cloud architects, right? They figure out, like, we're going to use these different cloud services to build a solution and whatnot, okay? Software architects are also typically involved in technology selection, right? Are we going to use Quarkus or Spring, right? That's actually not a great question. A better question would be, for example, we've been using JMS, or we've been using some kind of message queuing type of system underneath the hood to build features or whatever, right? So this could be something like IBM MQ series or ActiveMQ, right? Just standard messaging. And then a few years ago, you may have heard of this thing called Kafka and this kind of evolution towards event streaming. So as a software architect, you may say, you know what, we may actually avail of this type of architecture to build better features that provide, real-time analytics to our users, or whatever it may be. So architects are typically involved in something like that. Not always, but again, it depends on where you are and what the company does. The last one is something that I did quite a bit. Before I was at a startup, this is several jobs ago, I was a performance architect at AT&T. So my job was basically a high and low level performance architecture. Okay, so this is where a lot of my background in Java performance comes from. I spent 7 years as specifically a Java performance architect. But being a Java performance architect meant that I had to go all the way down to the nuts and bolts, right? Basically Java code and PL SQL queries, all the way up to a high-level systems design. So it was all-encompassing, top-to-bottom type of thing. But I was still an architect because I didn't really code that much. I was more concerned with the systems design and architecture, and lots of little things also in terms of how we write code and different kinds of algorithms we use and stuff like that, right? But I'll talk a little bit more about that later, okay? All right, so some other things that architects do. I spent some time setting internal guidelines and best practices because I was responsible for performance across a team of about 200 developers. So to make sure that it was a very large team, there were multiple teams, right? But the larger team was around 200 developers, which is quite big, as you can imagine. right? And then, of course, someone with that level of responsibility requires a large amount of collaboration between teams, and also has to show leadership and all the things that come along with that. We'll talk a little bit about all these things in a few minutes. All right, so one of the main questions I get when I talk about software architecture, whether it's this presentation or other ones I've done in the past, is how involved should a software architect be with coding, right? How far removed should they be from coding, or how much coding should they actually do, right? So the answer is, of course, it depends, right? So who are the people who raised their hands a few minutes ago when I asked who was a software architect? Okay, we'll start with you, Jonathan. How often do you code as a software architect? What's the size of the company that you work at? Let's start with that.
Yeah, we've got about 15 developers that
Okay.
fit into that category that you're talking about with like principal developers also filling
Right.
architecture roles.
Wear a couple of hats, gotcha.
Yeah. It depended. For a while I was a team lead and I was living in the bug tracker and meetings, and I wanted to be coding and I wasn't. And
Right.
now I've been relieved of that responsibility and I'm coding every day.
Okay, interesting. All right, so you also raised your hand right here?
Yeah, so currently I'm in a similar position, so wearing multiple hats. I'm not formally an architect.
Okay,
Previously, when I was formally an architect, I had, again, two distinct positions. One of them involved coding proof of concepts and also helping develop production code, but at a higher level, at design level.
okay.
And the other one where I was completely removed from coding, and it sucked. So I don't think that's a good role.
I got you. So how much of your time do you think you spent coding? 50%? Maybe 20%?
Something around that, like
Okay.
50-40%, slightly less than half.
Okay. All right, there was somebody else who raised their hand right here.
Yeah, I did.
Yeah, go ahead.
Yeah, I was not coding at this point. When I was just doing architecture, or the team was probably bigger, and that was no time, or less and less, and eventually not at all. So
Okay.
I kind of liked it at the beginning, because having multiple hats, I had the feeling I was producing nothing.
Right.
Not enough architecture, not enough development. Then I was feeling a bit better when I did only architecture, but I was also feeling disconnected because I have to choose the technology, but I didn't try the technology. So I saw a YouTube video, I went to like a conference talk, and that looks amazing. I would
Right.
put this on my team, but the poor maybe engineer would hate me because I picked the wrong technology, and I have no
Right.
idea if it was the good one.
So thank you, Christoph. We're actually going to talk a little bit about exactly what you said, but you are what we call a sticks and boxes architect, right? So it's a little bit of a joke, obviously, but somebody else want to volunteer? Yes.
Yeah, so I work as a company that's very small. So I basically work as a software architect, but the product I'm working is pretty new, and then none of the developer has any experience on that. So basically, most of the time goes on architecting the product.
Okay.
And the rest of the I'd say 70% of that, and then 30% is just like developing the product just because no one else can work on that.
Okay.
And I also, from the architect perspective, I do find as long as the architecture is solid, there's like less programming needed to be done, less changes needed to be done, which is also why I usually prefer to do it certain portion by myself.
Okay, cool. Anybody else want to volunteer their experience? No, it's okay. So, but you see, here's the thing. For those of you who are software architects, that's great because the AI is going to do all the coding soon, so you're not going to need developers, just architects, right? It's a joke, of course, right? Actually, that's a good segue, real quick, because I know this is on everybody's mind, right? Everybody in this room is obviously a software developer or an architect or something. But there's this, I don't normally recommend like people on YouTube or like, hey, you should watch this because there's just so much stuff out there. But there's this guy that I watch, his videos are fairly short. This is one of the longer ones. But this is what it's called. I can send the link out, or I can send it to Jonathan or Teresa, and they can send it out to everybody or put it in your Slack, right? But he just put this video out a few days ago, and he has one previously where he was talking about the AI bubble. But I'll just very quickly summarize this video, right? I'll be like the Notebook LM for the... Have you guys used Notebook LM, by the way? Are you familiar with it? Yeah, if you're not familiar with it, it's something you should use for sure. Like I use it almost every day if you're not using it. Basically, you can feed it documents or YouTube video links or whatever, and you can just say, go and summarize this for me. Or you can say, I want to do X with this, this information. Anyways, you should check it out, Notebook LM. But anyways, getting back to this, what this guy is saying is that I think it's what we all inherently know with this software architecture stuff. Well, I'm sorry, with this artificial intelligence. There's a spot right here if you want to sit up front, or over there, yeah. Is that everyone's so worried, and rightfully so, that all these jobs, that coding jobs or development jobs are going to go away, right? And actually, Mark Andreessen, who's a VC, the guy who founded Netscape, is a bit of an asshole, but we'll talk about that over a beer a bit later. Even he said the same thing, which is the demand for software engineers is not going away. Right? What's currently happening is that we don't know what the hell is happening phase. Right? There's a lot of uncertainty, and a lot of the layoffs that you hear from from the big companies, right? Like especially Google and Meta and whatever, Microsoft. They're laying off people left and right because they're using that money that they used to pay developers to buy all these NVIDIA GPUs, right? So I've made a shitload of money this year over the last year because I bought NVIDIA like 2 or 3 years ago when this AI thing took off because I knew it was going to happen, right? Everybody did, but I had some cash laying around, so why not? But the reason why that the need for software developers will continue to go up. Let me rephrase that. Not developers, but engineers. Like there are a lot of people who are in software development, but they're not hardcore engineers like the people in this room, right? They do some of the ancillary tasks, right? Like let's say a QA person. And I'm not hating on any of these people, by the way, right? QA people will still be needed, but they will also need to adopt AI, right? But the need for software engineers will actually be more acute because AI at a very fundamental level is non-deterministic. So you never. What that means is you never know if what the AI is going to produce in terms of code is going to be 100% correct. So someone has to figure that out, right? And also it becomes a little bit of an arms race, if you will. So if you work for a bank, right? Let's say you work for RBC, and what's the other bank in this country? Scotiabank, is that right? Okay, there's Scotiabank, right? So you have 2 rival banks in this country. You have developers at both those countries. I'm sorry, at those companies, not countries. If RBC goes all in on AI and all their developers use AI, they're going to go way past what Scotiabank can do, right? They'll basically leave them in the dust, and Scotiabank won't exist 5 years from now because this other bank has done much better, right? It's competition, right? It's probably not true. Maybe that's not a great example, but you get the idea, right? It's like if one company in your vertical or your sector starts using AI, everybody else has to use it because otherwise you get left behind. So what will happen is that as developers, and again I'm paraphrasing what this guy is saying, is that we still need developers, and when developers will still be doing software development, but it'll look a little bit different than what we do today. We'll spend less time writing boilerplate code and more time focused on features and honestly checking what the AI is doing and building more advanced features, using AI, maybe not using AI, right? But systems design and all that kind of stuff will always be around because someone will invent something new which the AI can't currently do because it's not been trained on. So for example, if you don't believe me, go ask any of the newer AI models. You were talking about how Java 25 is coming out. Ask it to build a foreign function example for you. The foreign function access API is new in 24 and 25. Not a lot of great examples. If you feed that into ChatGPT, it will give you an answer which is wrong. I've tried this. Okay. Anyways, enough of the little sidebar and soapbox on this. You should check this out. This guy has some good stuff. He talks about engineers and all that kind of stuff around it. Okay. So let's get back to this and talk about speaking of coding, why architects should code, right? So, so Christoph touched on the first point here, is if you're an architect and you don't code, or at least have a really, really good and deep understanding of coding practices and what's the latest stuff coming out in Java 25 or whatever, you won't have credibility, and you won't have proficiency to be able to make informed decisions which are good for your team. okay? And you also won't be able to understand what are implementation challenges and trade-offs. If you don't know what the low-level code can and can't do, then you can't make these decisions in a good way, okay? And of course, that leads to leading by example and earning respect, okay? So there's some reasons why you shouldn't code frequently if you're an architect, which is time constraint, right? That's the biggest thing. Nobody wants to work 80 or 100-hour weeks, and even if you do, you're not going to produce great output if you're working that much every week for months and years on end, okay? So you have to focus on something. Right? So one of the things that I do at my job, there's a 2-letter word that architects have to get really good at saying. Does anyone know what that word is? No. The answer is no, all right? Because oftentimes you're the first line of defense when someone comes to you from the business or management and says, we want to do this, and then you have to say no, right? But you get really good at saying that, and one of the things that you have to understand sometimes is that, especially as an architect, if you get, you will be pulled in a lot of different directions, right? I asked folks in the room what kind of stuff they do, and everyone said, I wear multiple hats. Well, how many hats can you realistically wear and still do a good job? Okay? Coding may not be one of those. Coding is extremely brain and time intensive. Hence, if you can't dedicate the time to it and do everything else, maybe you shouldn't code. It doesn't mean you shouldn't keep your skills sharp, but something that you have to at least understand and be aware of. Okay? So, the other reasons why architecture and code is there's a risk of micromanagement, right? Even on a small team, you'll have principal or senior developers. Those people deserve airtime. They should be able to use their skill and their talent to help the overall team produce good software. And of course, there's the potential for bias as an architect. If you're into code too much, then you may bias the team in the wrong direction. Again, letting your other developers, they could also be junior developers, right? This is not to say that junior and mid-level developers don't have a contribution to make. They can also make a valuable contribution. So staying open-minded and maybe staying a little bit back from daily coding is a good thing, right? Again, it all depends. All right, so I'm going to skip this because we already talked about this stuff. Right, tailored to the specific context of a project and architect's role. So it varies from company to company, okay? And then we talked a little bit about collaboration and communication. And this is where, when I'm talking to younger folks who are, maybe younger is not, people newer to the software development industry, and they're saying, oh yeah, I want to become a software architect. Well, the first question I ask is, well, are you good at talking to other people? Can you communicate verbally and in a written way very concisely and expressively? And more importantly, is that something you like doing, right? Or does that annoy the crap out of you? Okay? And if the answer to those questions is no, then you're probably better off just being a developer. You can be a great developer and have a great career. You don't have to be a software architect, right? Unfortunately, the way that, especially at larger companies, the way things are structured is that when you move up the career ladder, right, you start as a junior developer, then you're a mid-level developer, and then a senior or principal developer. The next logical step is either management or software architect, okay? Now, how many people in this room think that anyone who's made it to a senior or principal developer is automatically a good manager? Right, nobody. Nobody, okay? Everyone in this room has worked for someone who was a software developer and became a manager, and they were not a good manager. Okay? Same thing with architects, right? Because of the need to collaborate and wear multiple hats, right? Like I'm a software developer and have always been that. I've done a lot of different things, but I actually really enjoyed just doing software development because I could go sit in my corner and for 6 hours a day, I could crank out code and then I could go home, right? It was great. I didn't really need to talk to anybody that much. Of course, I had meetings here and there, but I have to spend half my day talking to people and explaining stuff or whatever, right? And it was great. But I wanted to do more things, so I became an architect and I specialized in performance architecture, which is because of my background in engineering at university, it was a natural fit for me, okay? Anyways. All right, so let's get into some of the extra topics here, some of the more additional topics here. and talk a little bit more, less abstractly and more concretely about code quality, software architecture, and just code quality in general. Okay, so these are the topics we're going to go. Okay, so the first thing I want to talk about is how do software architecture patterns help produce better software and code? So the patterns I'm talking about are not the low-level patterns, like from the Gang of Four book, right? What's the name of that book? I've forgotten.
Design patterns.
Is it just called design patterns? I always thought it has like more of a, okay, anyways. Right, so, yeah, okay, thank you. So that book has low-level code patterns, like the observer pattern or the adapter pattern and things like that, which are all very useful down at the code level. That is not what I'm talking about, okay? So these are higher level patterns which are either at a systems level or kind of, let's say, at the component level almost, okay? But I put together this diagram to give you a better idea of like how I think about this, okay? So we'll talk about each one of these very quickly here, okay? So the way software architecture goes down into the coding layer is here kind of at the top, right? So if you have a good software architecture, it helps you build a solid foundation for building and engineering code, right? So that includes having developers on the same page. If everyone is using the same style of coding, they're using the same tools, it helps increase the team's overall velocity, okay? And it makes things much easier, right? If I'm on vacation, which I like to go on vacation occasionally, I know that somebody else can pick up my code, and if there's a bug, I don't get called while I'm at the beach, okay? That's very important, okay? And as a software architect, one of the things I did is I built up a knowledge base, right? This is one of the things I didn't like doing, which is writing a lot of documentation. So I tried to automate as much of it as possible, but I still had to write documentation on what the software architecture looked like. And again, I was in charge of performance architecture, so I had detailed documents of how everything worked and things you should do and things you should not do. Okay? So speaking of things you should not do, actually we'll get into that story in a minute. Okay? Now, the second part is if you have good software architecture and you use good software architecture patterns, it helps manage complexity and makes maintenance easier. Right? So everyone strives to have less bugs, and everyone strives to have good low-level and high-level code reuse. Okay, so that's having the high cohesion and loose coupling principle that all of you are probably familiar with as software developers. Okay, so the last thing is a little bit more on the kind of team side, which is scaling a team and the platform. So if you remember about 10 years ago or so, we didn't do continuous integration or continuous delivery as much as we do today. But there was this whole movement around it, and so that's where this deploy faster and more often is, right? Like if you think about yourself 10 years ago and you said, wow, we're going to deploy every day or every hour, you probably said to yourself, that's insane, right? There's no way that we can do that, right? But today we can. And that's because we came up with these software architecture patterns all the way from the top to the bottom in terms of being able to structure a team, the way we manage code, the way we do testing, the way we even write code. You know, we went from building monoliths to smaller microservices, which allowed to do more rapid deployments. Because as you know, it's much easier to frequently deploy a very small system as opposed to a giant monolith, right? If you're deploying a giant monolith, it usually requires lots and lots of time and work, and there's a lot of risk involved. Whereas if you deploy microservices, it's easy to test, it deploys faster, et cetera, et cetera. Okay? And so that can potentially lead to larger teams where you can have more people working on them. Now, there should be an asterisk next to larger team, because a larger team is always not more productive than a smaller team. Okay? So again, for the folks who are a bit newer to software development or software engineering, there is a great book that was written many years ago, decades ago, in fact, called The Mythical Man Month. How many people have heard of that book at least? Right, so a lot of people have. So the guy who wrote the book, his name is Frederick Brooks, and he was a professor at the University of North Carolina, which is where I went to school. Okay. And I actually took a class with him. This is a long time ago. So it was a great class on basically like how to build software. It wasn't like writing code, but it was like software teams and things like that. And the things that he stressed, and there's actually a common saying, and this sounds it sounds a little weird. You may have heard the saying, but basically, and someone help me if I get this wrong, right? You can take one woman and 9 months and produce a baby, but you can't take 9 women and 1 month and produce a baby, right? So if you want to kind of summarize it, that's the way to think about it. But the core of his book was that if you have 5 people on a team and you add 1 more person to the team, that doesn't mean that that team is 20% faster now, okay? Because of the communication overhead of having that extra person, that person may only add 5%, or if you're lucky, 10% extra capacity to the team. So, what's that? Right, exactly. If you add the wrong person, maybe minus 20%, right? So, 100% right? So anyway, it's just something to think about. So I put larger teams there in asterisks, but I think this larger teams in terms of if you have good documented software architecture, you can have multiple teams working around the same kind of stuff, right? So one really good example of a modern software architecture project which avails for larger teams or for more people to use the same system, if you will, is something called Apache Iceberg. Has anybody heard of Iceberg? So a few people have. If you haven't, Apache Iceberg is the successor to like Hadoop and Huddle and some other big data systems, okay? Now, it came out of Netflix because what they do is every time you watch a TV show or a movie on Netflix, what you should feel good about yourself, because what you're doing is you're helping to advance the state of software, right? Because what they do is they take all this data and they produce all these great tools and platforms and they open source them, because a bunch of stuff has come out of Netflix. For example, Iceberg. What else has come out of Netflix? What's that? Hystrix? Yeah.
All the microservices.
Yeah, the microservices architecture. Like if you look at the Apache projects in recent history, a lot of the big data projects have come out, like Iceberg, have come out of there. The reason why I mention Iceberg is because what they did is they figured out that if we can't keep using our stuff here where we bundle, essentially, we can't keep using databases. That's the premise they started with. Right? Because what databases do is they bundle storage and compute into one magic black box. Right? That's what a database server is. You have compute and storage coupled together. So they said, hey, let's decouple it, which is what something like Hadoop does, and then we'll put stuff on top of it, which is the compute, i.e. we'll reach into the data set, or anybody can reach into the data set, this Hadoop data set, and use it. What they did is they took that one step further with Hadoop, and they said, how can we make this more practical so that we have these giant data sets? How can we have multiple teams use them and it's easy for them to use? So they created this thing called Iceberg, which allows multiple people to use these giant data sets. There's a catalog in front which describes a schema. It allows for schema evolution and allows for time travel, et cetera, et cetera. My point is that because of the architecture of this specific big data system, multiple teams are able to use it, or larger teams are able to use it, right? That's what I mean by that, okay? So anyways, I have a great presentation on Apache Iceberg and doing analytics with Spark. If you'd like to see that at your company at a lunch and learn in person, the Azul sales guy actually lives here in Toronto. So I'll come down, you get 10 people in a room, he'll buy the lunch, and I'll give you a presentation on Iceberg and Spark and how to do like basically big data architecture with that. If you use Snowflake, you're actually using Iceberg underneath the hood, but you don't want to pay Snowflake all that money. We're engineers. We like to build stuff ourselves, right? So anyways, let's move on. All right. So we've already talked about this stuff already. This is just a drill down to make sure I didn't forget about the different points for those different segments that we talked about here. Okay. We can have people working in the same stack, knowledge of overall system and design, managing complexity. Good architecture leads to lower bugging code. It gives you better reuse. And then scaling a team, better code quality means faster releases and also better reuse. Okay, so let's get into processes for a bit and talk about things that architect, and again, if you're not an architect, this is interesting for you because it might help you understand how to work with your architect on your team. Okay, so as an architect, one of the questions that we commonly get is, should I get involved in high-level code reviews? And again, the answer is it depends. When I was a performance engineer, I got involved with things all the way from the top to the bottom. So that may not necessarily be true for everybody, but definitely can be true. So I would get involved in low-level code reviews because I cared about performance at a low level as well as the high level, right? So I did code reviews from top to bottom, right? So I'll give you a great story around this. I was doing a code review once, and one of the developers on the team had put in a system.exit in his code. Now, what does system.exit in Java do? Right, it terminates the process right now. No graceful shutdown, it's bang, you're done. It's the equivalent of a kill -9 on a process, right? So I said to him, I said, why is this here? This seems dangerous to me. He said, oh, no, it's just here for testing. And he like showed me like the code path and stuff like that. And fair enough, he just wanted to test some stuff out, and then he wanted to exit like when the test was done so a bunch of other stuff wouldn't run. And I said, okay, that's great. And he said, oh, don't worry about it. It'll never get called. Right? Famous last words, of course, right? So I said, please remove this from the code. Comment it out. If you need to absolutely use this, just uncomment it, and then make sure you, whatever. But I said, please just completely remove it. Better yet, write a unit test that does something like this, okay? And this was a senior developer. This wasn't like a junior dev either. So a month goes by, and my pager goes off at about 2 a.m. on a Saturday when they're doing a deployment. And they're like, this server keeps, the system I worked on had about 30 to 40 different discrete components or application servers with large modules. Basically, it was a distributed monolith is the best way to describe it. You can move that stuff over. And they were like, yeah, this one specific service keeps going down, and it just kind of goes down randomly. I'm like, oh, okay. And then the light bulb went off in my head, which was that, oh, that's right. One of the developers put this in, and sure enough, that's what happened. Somehow, even though this developer had sworn to me that this would never get called in production, guess what? It got called in production, right? And it ruined my Saturday night. Thankfully, I hadn't been out drinking that evening, so I was sober enough to remember that. Otherwise, that would have been fun to try to figure out after 5 or 10 beers what was happening, right? So anyways, one of the other things I did in terms of performance, in terms of code reviews, was I also looked at different types of way people structured code, right? I cared about cyclomatic complexity, which we'll talk about in just a second. But I also, not too much, but this was like 15 years ago, right? One of the great things about the Java virtual machine is that it has the JIT inside of it, okay? And for those of you who don't know what the JIT is the just-in-time translator. What it does is it takes the code you write, even if it's good code, and it makes it run more efficiently at runtime. So it basically monitors how your code, you put your code under load, it doesn't matter if it's on your desktop or on a test server. Whenever you start Java up, unless you've explicitly disabled the JIT, it will kick in and it will try to optimize your code, okay? So, for example, if the JIT compiler detects, right, again, your application is being under load, right, code paths are being called, what the JIT will do is it will, for example, say, okay, you're calling this method, which calls this other method, and you're calling this over and over again. You called it like 1,000,000 times in the last minute or something like that, okay? So the JIT says, you keep calling this thing, and I'm going to make an optimization here. And I'm going to take that method, calling this other method, I'm going to take the child method and just put it directly, I'm going to take the bytecode and inject it directly into the path of the parent method. That's an optimization called method inlining, okay? So what that does, and you might think, well, how does that really help? Well, whenever a method calls a method, it puts something onto the stack which consumes a little bit of CPU and memory, and then pops it from the stack, right? Which then also in Java, creates a little bit of garbage, right? But it's a very, very, very small amount, but you do that millions and millions of times a minute, and it all adds up, okay? But anyways, that's something called method inlining. There are other things like other optimizations, call-side caching, and stuff like that. I actually have a whole presentation on that. Again, if you'd like a lunch and learn on stuff like that, I can go into some of the things that the JIT does. So anyway, my point of this story is that 15 years ago, the JIT was really good, but the JIT gets better over time. So nowadays, I don't really worry too much about really low-level optimizations in the code that I would do by hand, because the JIT will just do it for me. But there are high-level things that the JIT can't do. So for example, the difference between using just a standard list and an array list versus a linked list. There's a huge difference in terms of the performance between those two, right? And access into an array list is basically O of n. O of n? No, it's just n, right?
No, but O1.
Oh, O1, I'm sorry, it's O1. It's the linked list, which is a O of n. Thank you, okay? So I would look for things like that. So that's why I got involved in code reviews, because when people were using the wrong data structure, I would gently go back to them and say, hey, maybe we should use this instead of that, okay? And these optimizations added up over time, okay? So if you're not familiar, or if it's been a long time like it has been for me, since you've looked at like these different types of algorithms that you can use in code, there's an excellent book called Grokking Algorithms, Grokking Algorithms. Anybody read that book, by the way? Okay.
I read a little bit.
Yeah, it's an excellent book. I started reading like a much larger book, which was very dense, and it was like, you know, a university type of book, and I was like, I can't read this. This is like better than sleep medication, because it puts me to sleep right away, right? So, but I started searching around. I was like, there's got to be something better. But anyways, this is a great book because it has lots of pictures, and I like to learn visually rather than by reading books. So it's got nice diagrams and pictures. Anyways, if you're interested, you should check that book out. It's worth reading. Okay, let's get back to this. Processes. So one of the things I did is I set up coding guidelines. One of the first things I put in there was don't put a system.exit in your code. Okay, so. As you can imagine. And then I spent a lot of time, because I was in charge of performance architecture, performance test, and reviews, right? And I have an entire presentation on this. So if you'd like to see this at some point at your company, either over Zoom or Lunch and Learn, please let me know. I'm happy to do that. Okay? Actually, I have 2 or 3 different ones on performance testing and architecture, because that's what I do a lot of at Azul. Okay? So, second thing is technology, library, and selection. It probably goes without saying that you can't let anybody just bring anything in and throw it into your application without some kind of review or thinking about it, okay? And this is not just from a code quality point of view, but it's also a license thing, right? So for example, I was working with a customer recently, and they wanted to use our code inventory tool to detect if people were using the akka framework, AKKAA. Does anybody use akka in here, by the way? What's that? Okay. So anyone using it currently, out of curiosity? You're using it currently? Are you still using it after the license change?
That's an interesting point of contention.
Okay, right. So this is the exact point I was trying to get to here, which is that Akka changed their license to basically make it's still like open source, but they changed it so that now you have to pay for it. After, I don't remember do you remember what version it was? It's like 1.3. Yes.
Phone somewhere.
Right. So anyways, this customer was like, we don't want to keep using this because they've changed the license. It's still open source, but now we have to pay for it if we go from version, I don't remember exactly, but from version 1.3 to 1.5, now we got to pay for it. We don't want to be out of license compliance. So they're doing what you're doing, which is they're slowly trying to back out, using it and finding some of the framework. So anyways, my point is as an architect or even as a developer, you have to be careful and cognizant of this, not just from a code quality point of view, but also a licensing point of view, because this does happen. What was the latest? There are a few things recently. I don't think they were libraries, but they basically just changed they ripped the Band-Aid off and said, it's no longer free, right? We're going from like GPL to a Faro GPL. Do you guys remember what that was? HashiCorp did it. That was with Terraform. That's right. Yeah. I'm trying to think who else. I feel.
With Redis, am I remembering?
That's right. I believe Redis also did the same thing. Yeah. Yeah. I feel.
Change it back, by the way.
Oh, they did change it back.
Yeah,
Okay.
they lost a lot of money.
Yeah. I guess a lot of people were like, okay, we're not using this anymore. But, anyways.
Docker or like the other companies.
What's that?
Docker, like the containers.
Yeah, Docker, yeah. Everyone's trying to monetize now, right? So, anyways, so this is important, and I think the last point I want to make here is that you can't be the only one on your team as an architect who is bringing ideas to the table for what libraries we should use. And this can, right, I gave previously an example of going from message queuing architectures to event streaming architectures, right? Going from something like ActiveMQ to Kafka and event streaming, right? Because I think that everyone on your team will have good ideas about stuff. So you don't want to quash these ideas and deflate people, because then you just make them a drone that is easily replaceable by artificial intelligence. I'm joking a little bit, of course, right? But keeping an open mind about this and allowing people on your team to suggest things. And then, of course, what I would normally do is, that's a great idea. Go and do a quick prototype. Don't spend more than a day on it. And then, and because again, I was responsible for performance architecture, and also tell me what all the performance implications will be, okay? And then we would have a discussion from that point of view. Usually, like 80% of the time, I would never hear back from that person. But that 20% of the time, they would actually come back with some really nice POC, how it fit into the architecture and all that kind of fun stuff, so, okay? All right, so on the home stretch here, yes, go ahead.
Question, if you don't mind.
Yeah, go ahead, of course.
I don't want it to sound in any like negative way, but in your previous slides and in the last one, you had like an architect is a gatekeeper of no libraries without the permission of an architect, and then coding standards, and especially when there are these types of architects that grow detached from practice of software
Yes.
development, and they become those gatekeepers.
Yes.
What would you say about them becoming the impedance in the way of modernization?
Yes.
Because unfortunately there are some companies that have these kinds of approaches, and it's very painful.
Okay, so what was your name? I'm sorry.
Yaroslav.
Yaroslav has a great point, right? Which is oftentimes these architects can become a barrier or a blocker for modernizing your system. I 100% agree with you with that, okay? Now, let me start from the beginning though. You specifically mentioned like the architect has to be the gatekeeper for what libraries or tools you use within your software development project. I still firmly believe that, right? Because somebody has to be the police for something like that, right? I gave the example of akka, for example, okay? And right now with artificial intelligence, like at my company, I can use AI for the stuff that I do, but I'm not building code that's the code for the actual software product that we build. I build like demos or helper tools for it and stuff like that. So if I were to use AI and it pulled in some GPL code or whatever, some kind of license code that we can't use, my legal team would have to say, okay, you know what, that's fine. We're just going to rewrite this. It's not all the way down in the core of what we actually sell. It's a helper tool, and it would be a lot of headache. Right, but somebody has to manage that. Someone has to be the gatekeeper for that, unfortunately. Okay. With that said, the stuff that I've been talking about is when I was a performance architect, there were several of those people who were on the architecture team. They would say literally no to everything. Okay, and I fought with these people all the time. Literally fought with them. Like shouting matches in the hallway kind of thing. Because these people never wanted to change anything. Okay?
I've been in the same situation.
Right? But that's in the unfortunate reality of it, right? Because someone has to, it can't just be chaos, right? And then it can't be too rigid. You want to find something in the middle, right? You have to have some control and some structure, and you don't want to have total chaos where every developer can, or every team can do whatever they want. Because then you get fragmentation across all the tools and the coding standards and everything that you're building, right? So it has to be somewhere in the middle. How do you deal with these people? That's a human problem, right? Unfortunately, that's the reality of the situation. So I agree with you. These people who are a barrier to making progress, and they still think that monoliths are the best way to build software, and whatever, right? There's 100 different things, right? So,
A quick follow-up. Would
yeah,
you
go ahead.
agree that there is a balance between like liberalism in what you allow in your engineering organization and being more restricted, and in both in both kind of sides of that spectrum, architects have still value, and they could contribute to liberal engineering organizations as well as to stricter ones.
Yeah, I 100% agree with your statement. So unfortunately, people will be people. Humans will be humans, right? There will be people who've been, and I don't want to sound ageist, but the people who've been at a company for a very long time tend to be very rigid in their thinking and don't want to make, even small changes sometimes, right? And the best thing to do is to move that architect onto a team that is not yours, okay? Yes, go ahead. Sorry, I'm not trying to make fun of what you're saying, but that's literally what I did,
I think you
right?
agree with
Yeah, I 100% agree, right? But that's literally what I did. I started a little whisper campaign against one of these architects, and I didn't make any lies up. I just said, look at all this. And I said, I don't want them, he's impacting the way that we do deployments and slowing us down. And I moved that person, that was somebody else's problem then. So anyways, go ahead.
Yeah, so I have a question regarding being an architect and developer at the same time. How do you find the balance? Because
Yeah.
if I'm an architect, I can actually design the entire flow and then run into, go for the certain path that will not get me into any trouble.
Right.
But as a developer, I do want to explore different things and get more functionality, features, and everything. So how do I find that balance between that?
Yeah, that's a good question. I don't think I have a canned response for that, right? It's one of those things where there's so many different factors that come into it. Because of specifically what I did as an architect, I was always down at the code level. Not always, but frequently down at the code level, right? I didn't write a lot of features. I wrote parts of the code base which were used by multiple people. So I wrote libraries that other people use, right? So that's how I narrowed down my focus in terms of the stuff I wrote, because this was the stuff that was really important to performance. And it's not that I didn't trust anybody else to write it, but I was like, I'm just going to write this myself because it's the most efficient thing to do, right? And then I would take a step back, and there'd be all the other things I talked about in terms of architect stuff that I used to do. So that's the best answer I have. Just like his question, unfortunately, there's not like a recipe or yes, these are the 3 things that you should do for that kind of thing. So okay, all right. So a few more things. We're going to talk about code really quickly. And then I'm going to get a beer. So we're going to talk quickly about Sonar, JArchitect, and there's a bunch of other tools here, okay? But everyone has probably heard of Sonar, Sonar Cube, or Sonar Source. Hopefully you're using it. Everyone uses this probably, right? Is there anyone who doesn't use this? Okay, so this seems to be like a standard. It's like open source and it's basically free. And if you're not familiar with it, Sonar basically wraps a bunch of other tools underneath, like check style and find bugs and other things like that, and gives you a nice dashboard. Okay, so I'm not going to talk about this since everybody uses. But
you want the IDE plugin as well.
what's that?
Do you want the IDE plugin
Yeah.
for Sonar Lint as well, because it really shortens the feedback.
Yep. So Jonathan's suggestion was if you're not using it, use the IDE plugin for Sonar Lint. It makes the kind of cycle around it much faster. Absolutely right. Okay. Well, what I do want to do is take a second to talk about, for example, since this session is on code quality, to talk about code coverage, right? Because this is a common thing that probably everybody in this room does, right? So if you're not familiar with it, code coverage is you have unit tests. When you exercise those unit tests, it measures what code is actually being run, okay? And so it lets you know that your unit tests have coverage for this code, and you get a number out of it, like 50% or something. So let's go around the room really quickly and get an idea of what level of code coverage you have on your project and what your target is. So let's start with Jonathan real quick.
Yeah, we don't set an absolute target.
Okay.
But, we cover probably like 60% of the most important stuff in unit tests.
Okay.
And then we also have an end-to-end test suite and
Right. So end-to-end is integration testing, basically. Okay. Anybody else? Yeah.
So for me, the company I work for, we deal with personal health information, the PHI. So we do have to make sure that everything that we write is like absolute. So
Right.
we have to make sure that we have full coverage, but that's also because of the use case itself.
Right. So what level coverage do you aim for with code coverage?
I would say like 100%. Like anything we do would have to be tested for sure.
So you strive to get 100% code coverage.
Like 100% as in like we try to like test every function that we are using. It's more of like from the front end we have to make sure that everything is working
Sure.
correctly.
Of course.
Because even a small mistake from like one person to another, like
Yeah.
actually get into it.
I understand. Yeah. Anybody else? Yeah, go ahead.
When I used to be a dev lead, it was 95.
95%. I'm astonished by these numbers because, and I'll tell you why, right? And but what about you? What do you do, Yaroslav? You're an architect.
Well, no, currently I'm
Oh, wow.
not
Okay.
formally. And yeah, another number to respond, you should have 0.
Okay.
We currently have 39, but 2 years
How much?
ago, 39%.
Okay.
2 years ago, we had 0.5%.
Okay. Right. So you're on that journey to getting better coverage.
But for new project, it's 92%.
Yes.
So for new projects, you aim to get like 90% or more, okay? Right. So the reason why I bring this up is because the code coverage helps with quality, right? If you're writing unit tests and you're covering your test, and this is not like kind of low-level structural quality, but it's semantic quality of your code, right? You know it's tested, you've written tests, something that people do to get, like if you're on the journey to writing better, getting better code coverage, mutation testing is a great way to very quickly get better code coverage, right? It's kind of a more kind of automated, structured framework for doing it, okay? But when and this is a while ago, we aimed for about 60% code coverage. We had a very large team, it was hard to do, et cetera, all these standard excuses. But there have been, the point that I want to make here is that there have been several research studies done, and you can Google for them. Maybe I'll put a link in for next time. But there's several research studies done that say that once you get past about 80% code coverage, you hit, very quickly hit that wall of diminishing returns. So going from 80 to 85%, the effort that you put in, you get very, very small actual kind of benefit from that. You go to 90% or 95%, it dwindles even more, okay? So it's just something to be aware of, okay?
There's something else that I think as you strive for 100 is that you're starting to get coverage that's not backed by any assertion.
Right.
Just visiting code. And
Yes.
Yeah, that is a very, very good point. Like,
becomes
because
ridiculous
despite of, what I just said, like 0%, I had much more before on previous projects.
Yeah.
But I've seen multiple times when I was consulting in one company where there was a lot of code coverage with very little assertions. And maybe you want to bring the point about line, like different kinds of coverage calculation. Line code coverage versus logical branches code coverage.
Yep, 100%.
Which is very important sometimes as well.
Yeah.
I found without a mandate, it's easier to find code nobody's thought about.
Right.
Because it doesn't have coverage.
Right,
If you
right.
mandate coverage, then
Yeah,
it's hiding.
Yeah, I got you. That totally makes sense, yeah.
When I talk about 95, the way we got there was I enforced test-driven development.
There you go.
By doing TDD and starting there, every single case was just automatically hit.
Yeah, of course, yeah. If you're doing TDD, you're going to get really high code coverage, but you're not going back after the fact and slapping in test, right?
Exactly.
You're starting with the test and then moving forward. And so that's perfectly reasonable thing to do. So, yeah, go ahead.
Yeah, is it possible to get like 100% code coverage based on the logical sequence? Suppose like we have 10 options, so that's possible. Like there is 10 inputs or 10 different possibilities. So there's definitely not possible to get like logically get that much code coverage, right? What would be the
Okay, so I'm gonna use the presenter's right to take your question and answer a completely different question. How's that? Okay. All right. So the question, I'm going to answer a completely different question, but it's related to what you're asking, which is when, and this also goes to what Jonathan was saying about people just executing a method, and that code is now covered, right? One thing I noticed when we instituted this rule of at least 60% code coverage, is a few days before that person or that team's code review, there'd be a lot of check-ins for tests. And a lot of those check-ins would be, just go run this method, right? So the thing here is that, yes, having code coverage is great, but that doesn't mean anything if your tests are not of quality test, if they're not actually testing anything worthwhile, right? Because I can just execute a method, oh, it ran, great, okay? But that will show up in your coverage report as being covered. So anyways, what I'm trying to say is that I don't hyper-focus, even when I write my own stuff today, I don't hyper-focus on the coverage so much as, am I writing quality tests, right? And sometimes I use mutation testing to help make sure that I arrive at that place just by practice rather than by design. So, okay.
One great concrete example of where coverage may not help is where if you've got some sort of a decision tree and you've put in a default to catch new stuff people add later somewhere else, is
yes.
often very difficult to exercise from a test.
Yeah.
But it's better to have it than not, but you'll lose your 100% coverage.
Yes, absolutely. So the other thing along with code quality that I focused on quite a bit was something called cyclomatic complexity, which Sonar also reports. Okay, so if you're not familiar with cyclomatic complexity, what that means is how complex is this bit of code? And the way that I like to think about it is the higher the cyclomatic complexity for this code is, the harder it is for someone to read and understand that code. Okay, so for example, if you have an if statement inside of your code and you nest an if statement inside of an if statement, you have dramatically increased your cyclomatic complexity. And you do that, you do an if inside of an if inside of an if, and you've blown it like way, way, way high. Okay, so there are ways to ameliorate something like that, but sometimes you do have to have that level of conditional branching because the business logic you're working on just dictates that. Okay, but I focused a lot on cyclomatic complexity because we had a very large team of developers, and readability and understandability of the code was something that I really wanted to have across everything. Because guess what? It may be that Saturday night where I'm the guy who's on call and my pager goes off and I have to read somebody else's code. Okay, I don't want to throw anybody else under the bus. I have to read my own code and I don't know what the hell I wrote because I made it too complex on that day, right? Because as software engineers, we never over-engineer anything, do we? Never, right? So, or do premature optimization. Okay. So, anyways, just a few words there. I thought that might help some folks. Another tool that I used to use when I built large-scale systems was something called JArchitect. This is better for monoliths rather than for microservices. So, this is running against, for example, the JBoss web server one. I haven't used this tool in a while because I don't typically do monoliths that much anymore. But if you do, this is a great tool for like visualizing a monolith, and it has kind of interesting things. It has like a little way that you can traverse and things like that. So this is a good way to look at your system, understand it, and get some code quality metrics out of it. And then I talked about this a little bit already. I'm going to do a quick demo. So we have something at Azul called Code Inventory. And what it does is it uses a very, very slim agent, or if you're using our open source or any one of our virtual machines, the logic for this is baked into it. But you can use anything. You can use OpenJDK or even Oracle JDK. Use our agent, and it collects these stats about your application. And what it will do, and you run this on production, right? So I'm going to talk about DevNexus in a minute. But if you come to DevNexus this year, I'm going to print up these T-shirts that say, I don't normally test, but when I do test, I test on production. Exactly. So come and you get one of those T-shirts. There you go. Boom. And you think I'm joking, right? Hold on. Let me see if it's in this. It's in one of these slide decks. Which one is it in? Oh, no, not that one. This is a great thing about AI is you don't need a designer anymore. You can just spend 8 hours writing prompts to get the thing that you need, right?
Yeah, the architect can do the design.
That's right, exactly. So let me see if it's in this one. Since it's nearly the end of the night and I'm almost done. Here it is. See, you thought I was joking, right? It may not look exactly like this. I'll probably spend another 8 hours prompting something to, right? So if you come to DevNexus, I'll give you one of these T-shirts. How's that? All right. So with code inventory, we've had people like Netflix and other companies. I can't tell you all of them, unfortunately, but Netflix is one of our users. And I already spoke about Netflix earlier, like how they have amazing engineers over there. They have great practices. You know, they basically were the people who launched this microservices thing. You know, all these open source projects. Almost all the engineers I met from Netflix are really good software engineers, right? So anyways, they're one of our customers for our other stuff, and we got them to try code inventory. And they're like, yeah, we don't really need this. We're probably 5 or 10% of our code is not being used on production because they care about technical debt quite a bit. So they ran it, and they found 30 to 40% of their code across these 10 projects that they ran across was not used in production. And that's a low number. Other customers that we've had run it actually find upwards of 50% or more of their code that they're deploying to production is not actually being used. And again, what do you do with code that you're not running into production? You delete the F out of it, right? Not just delete it, because it reduces technical debt, it makes migrations faster, it makes it easier to understand code. You can go to new versions of Spring, you can upgrade JDKs. If you're like me and you like to use the latest and greatest stuff, if you're using DTOs, right, in your project and you want to start using records, go and delete all the code you're not using and then do all that transformation, right? And again, it pairs with Open Rewrite, just a second. Yeah, it pairs with Open Rewrite, so we have recipes for it. And someone mentioned plugins. So one of the guys on my team, Garrett Grunwald. Has Garrett been here in a while? When was he here?
He was here this year.
Was he here this year?
Yeah.
I should know this. He's on my team. When was he here? In April, I think? No.
So, no, he was at the
He was in March, right after DevNexus, right? Okay, right. So anyways, he wrote this plugin for IntelliJ IDEA. So this is the Spring Pet Clinic application that I have loaded into here. And this is really small, but what it allows you to do is you can see that for the Pet Clinic application, and you can actually run this. You can go get the Spring Pet Clinic application. It includes tests, and it includes a JMeter execution file, and you can run it. Then you'll have to get in touch with me to set up our backend and get an account and stuff, but I'm happy to do that for you. But you can see that their Pet Clinic, and I'm not hating on them because the Pet Clinic is just a reference application. It's not a production application, right? But you could see that when he ran this stuff, 67% of the code is unused, and we've actually had people come to us and say, we want to shrink our size of our deployments down and get rid of jar files. So this will actually tell you which jar files, from the jar to the class down to the method. It will tell you at those different discrete levels what is being used and not being used. Okay, huge time saver, and people are saving a ton of money. And then using that money that they're saving, moving those engineers onto AI projects, of course, right? So I'm not even joking about that. We had one customer say, we want to use this so that we can move people off of spending a lot of time on maintenance and upgrading and stuff like that, so that we can put them on future-looking projects, which are mostly AI projects. So, yes, sir.
Excuse my ignorance, but how does the tool determine whether the code is being used or not in production?
Sure. Right, so the question is, how does it determine that? What we do is we have a small agent that you can put in, you point it to our backend, point it to our backend server, and as classes are getting loaded, and as jars are getting loaded, and as classes are getting loaded, and methods are getting executed, it keeps track of what's doing that in a very efficient way, and it sends that metadata to the backend server, which you can then query using something like this. Oop, it's gone now, but you can query it using a tool like this, or we also have a web dashboard where you can look and drill down and see what code is being used and not used. But we're basically collecting that metadata at runtime. So what people normally do is they run it in their test environment first, just to make sure. I mean, it's just a small agent that doesn't do much really. It adds extremely small amount of overhead, less than 0.5% typically. But we tell people to run it on production, because that's where, you may have tests that exercise code that's not actually ever being used. So you run it, these people run it on production.
But that agent, is it just basically running a test? Like that's how
No, it's just watching, because the agent is plugged in down low into the VM level, virtual machine level, right? So it basically hooks in at the very, very low level in the virtual machine, and there's a very specific, it's both at the jar loader, there's a jar loader and a class loader. It basically plugs into the jar loader and the class loader, and then on top of that, it also plugs into, I've forgotten exactly what it's called now, but basically the method invoker to see what things are being called.
But it basically monitors a production.
Yes.
But how about if there's like an edge case, like that rarely gets called? Like,
Deleting, for example, one per month.
Yeah. So this is So that's a good question. So the best way to answer that question is that this is not something you just run for like a week or a day. You run it for a month. So we have one large customer using it. They have a 6-month process they're doing around this. They're going to run it for 2 months, and then they plug it into Open Rewrite. Open Rewrite will automatically mark those things which aren't called with an @deprecated flag or annotation. Okay, and then they're going to run it for another 2 months, and then it will set @deprecated remove equals true, and then at the end of 6 months, a human will look at this. An engineer will look at all the stuff it found, and they will make the final decision as to remove that code or not. But thing is, it's just narrowed it down from this much to this much, and they can go bing, 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 or just, you know what, we haven't used this feature in years. Hit that button, and all the code is gone.
Great. Sorry.
It's okay, go ahead.
One question. That means that every day you have some kind of report, and
It's cumulative, so it doesn't. Yeah, it collects the data and it rectifies it with the backend server. So it does add a little bit of overhead. Like I said, 0.5%, but it's not a lot. That's something we're very aware of. I mean, we build a virtual machine, right, all the way from the ground up. And in fact, like our high performance VM uses part of the OpenJDK code base, but it's actually based on LLVM, and whereas OpenJDK is not, right? So it's a different architecture at the low level. But anyways, my point is we build a VM from the ground up, so we're aware of all the little optimizations we can make so that it doesn't add overhead to something like this. Okay, yes, sir.
I have actually 2 questions. First one, I just missed how big is the overhead? Like how many resources consumptions it adds on top? And second question is how it handles dynamic class loading. That's what we actually have.
Right.
Yes.
Right. So again, it hooks into the class loader, and again,
class names are the same actually, but they are coming from different jars.
Right. I would have to get back to you on exactly how it deals with dynamic class loading, especially when jars come from 2 different places with different class loaders. But I believe the low-level metadata also marks the specific location where it comes from, and this is important, right? Because one of the things, a lot of people build Uber jars. If you're not familiar with an Uber jars, it's a packaging process where you open up all the jar files and you take all the classes out and you stuff them in one giant jar. And then some people still bundle the whole jars and then deploy, right? So either way, people are looking to reduce build sizes, and also there's another tool that can be used with this also, which is it's called AVD, or Azul Vulnerability Detection. And so it knows that you've loaded this version of log4j, which has a vulnerability in it, for example. And it can tell you that you're loading this one and this one. And it can tell you, well, you need to stop loading this one because this one has a specific bug in it. Again, it's just an example, right? Or it can tell you hey, you're using this version of Akka and this version of Akka. You shouldn't be using this one because the license has changed now. Right, so.
Yeah, our exact issue is we're loading thousands of jars
right
in runtime.
Right.
That's the issue. So, but yeah, that's great that it handles it somehow, at least.
Yes, it does.
About that, so that we just
absolutely. Okay. Yes, sir.
Yeah. So it might be my misunderstanding, but my question is about if the code is on production and we are comparing it with the test or the development branch. there's oftentimes that can happen that I might be developing a feature that might be coming in like 3 months into
Yeah.
production. So how does that handle that?
You don't typically run this in development. You can, but that development metadata will go to a different place. So you'll have like your that data set will be marked as development. You'll mark it as development, right? And this one will be marked as production. And for your specific use case where you say, oh, I'm working on this right now, it actually won't show up because you're not actually looking at what's running in production or what's not, right? It's a continuous process. So when you have that new feature in development today and you deploy it next month into production, then it will start showing up in the reports and, oh yeah, we're using this because we just built this feature and people are using it. Okay.
So basically, we do set up a time point where we compare the both.
Yeah, you can do time travel with it. Absolutely, yeah. Okay. All right. So final few comments. And again, if you're interested in learning more about this or having a demo, happy to do that anytime you like. Let's go back here. And how much time do we have, Jonathan? It's already 8 o'clock. I don't want to keep people all night, so.
Just a few days. Yeah. So if you see people start to like.
No one's fallen asleep yet, so I call that a win.
Just hit the table.
Yeah, yeah. I'm almost done. I saw that it was 8 o'clock, so I didn't want to keep people too much longer. Okay. Some other tools. Start from the bottom here. AI tools for generating unit tests. This is not something I've actively worked with. It sounds like an interesting idea, but it also sounds like it's not a good idea at the same time. Has anyone had any experience with this? This is actually a question from me to you.
Generation of unit tests?
Yeah.
Yes. Okay, so I have some specific observations.
Okay, please share.
So, if you have a unit test suite that's already doing some good stuff, and if you have a good unit test naming scheme, I have found you can basically one-shot a new unit test case and it will get it right and do the right thing, and it's like pleasantly correct. If you are starting in a vacuum and you've got like a new file and you're testing a new
Right,
thing.
or if you're working on an older project which doesn't have a lot of unit tests.
Yep.
Also, same scenario?
It gets really confused and it generates a test that usually creates some sort of a fixture or a mock and tests that, and it never actually visits you.
Okay.
I have a little bit of experience.
Yeah, please, go ahead.
implemented with that. And code generating AI is much better following existing patterns. So if you have a code base that has good unit tests, as Jonathan just said, like it will be more probable to produce a good test for you.
Okay,
If you have the test suite that sucks, it will create confusing one.
okay.
If you don't have unit tests and you instruct the AI to create unit tests for existing code, it will usually be garbage.
Really?
Because it will look at what your implementation is, and based on that it will try to cover it. But if you go the other way around, like hide the existing implementation from it,
Interesting.
describe the concept of what you want it to be, how you want it to function, then it could create meaningful testing.
Interesting, okay, because
Just put a bug inside it, just verify it, and everything is okay.
yeah.
It just asserts the code. That's all it
Yeah.
Oh, interesting. Okay.
It doesn't know requirements and behavior actually.
Yeah, that's right. You think that'd be able to figure some of that out at least, but again, I haven't had any experience with it because I'm skeptical at this point. Because you see these people who say, yes, if you have a legacy code base, use our thing and it will write all these great unit tests for you. And I'm like, really? It's like I've worked enough with AI at both coding and non-coding level to know that it's not going to be able to zoom in and do basically be deterministic for this. So
Like if your code base is perfect, and the assumption is your code base is perfect, you can assert that at that point in time, you can generate all the unit tests that will then detect any potential drift
right.
as you make changes later. But making the assumption that your code base is perfect is a bad idea.
But if your code is perfect, you don't need a lot of help.
Then you don't need the tests.
How do you
That's true.
know that it is perfect without tests?
You wear a T-shirt that says, I don't normally test, but when I do test, I test on production. So, Okay, a couple of things real quick. I didn't get a chance to talk about performance tools in here. I have a whole presentation on the way that I approach performance testing for Java applications. So happy to come back to Toronto and give that at some point. Not when it's really cold though, okay, Jonathan? I'm not coming back when it's cold.
So next year or not?
Yeah, next year I guess. Oh, is it? Wait, does it get cold here in September?
No, it depends on who you are.
Okay. All right, because I was thinking of coming up in November for Dev Montreal, so.
Yeah, it's not going to be too cold in November.
Okay.
It's perfect. November is the best.
Okay, good. All right, I may come back for that. Anyways, I heard you had an opening then. So, but if you're interested in doing that presentation over Zoom or lunch and learn in person, happy to do that also. Finally, there's this new thing, and this is just completely out in left field, right? Has anyone heard of this tool called Restate? I think their website is restate.io. This is actually fantastic. If you're doing something that requires like long transactions, it's basically like doing JTA but without all the crap and over like a heterogeneous type of deployment. What I mean by that is I want to call a cloud function, which then calls into a Redis backend to get some data, which then calls into, I don't know, some SQS or something, right? I just made those things up, right? But basically it allows you to do long transactions across like different types of things, and it manages all that for you. It's simple. It's similar to temporal.io if you've heard of that, right? But right, so this is similar, but I prefer Restate over temporal because I think it's a little bit easier to use. But it's worth checking out if you care, you know, if the system you're working on has complex transactions that spans like all these different things. So it's really cool.
Okay, maybe it's a very loaded question, but non-transactional systems, if they don't share like a transactional handling mechanisms,
Yeah.
what's
Right.
the mechanism?
So the question is if you have a non-transactional system that doesn't share transactional mechanism with it, how do you use it with something like this? Well, in that case, what you have to do is you have to write a rollback procedure, for example, for it.
So it does work like sagas and stuff like that? When you
Yeah, it's you can think of it like sagas, but you can extend them over different systems, right? And there's coordination between it. It's totally worth checking out, right? I built some stuff with this when I had to do something about 9 months ago or so, and I was like, wow, this is great. I don't have to like. It was basically I was trying to meld a Spark job with the cloud function and with the database call, and I want everything to be transacted. And I was like, well, how am I going to do this? It's going to be impossible. But this helped me do it really quickly because it provides like all the tools, libraries.
basically have compensating transactions?
Yeah, compensating transactions or rollbacks. That's right.
And you use the function for that instead of having some orchestrator service, right?
Yeah, it's kind of like an orchestrator, but not really.
Not really, but the
Yeah.
idea is the same. You need to you can
That's
use
right.
Kafka for that, not only
That's right.
anything.
That's right. But you can also use Restate to transact from Kafka to something else.
Yep.
If you wanted. So yeah, yeah. Go ahead.
Restate runs externally just like temporal would.
Yes. The short answer is yes. It's a little bit more complicated than that, but it's similar. Yeah. All right. And with that, we're 5 past 8 o'clock, and as they say in America, it's beer clock. At least for me, it is. I'm sorry. This QR code is expired, but there's no reason to put this up. But if you'd like to, I'm sorry about that. I forgot to regenerate it. I was busy, super busy right before I got here, and I totally slipped my mind. But if you go to linkedin.com/in/PR Patel, this is where you can find me on LinkedIn. So please connect. Happy to talk a bit more about this or whatever. Okay. So again, the QR code doesn't work, but linkedin.com/in/PR Patel. Also PR Patel on Twitter and prpatel.dev on Blue Sky. Okay. So thank you for. Oh, one more thing. I'm sorry. I forgot to mention. Jonathan talked about this earlier. I wanted to mention that DevNexus is coming up in March. And the reason why I wanted to bring this up, it's the largest Java conference, Java Focus conference, not just Java, Java Focus conference in North America. And the call for papers is still open until September 15th. So if you have an idea, put it in. We like to get people from the community in different parts of North America in. So we always have a few people from Canada speak at the event, and Mexico, etc., South America, all over the world, actually. There's a guy named Venkat. Have you heard of him before? He will be there again. He comes for the event every year, and loads of other folks. But you can join the big stage. We have a great time. Teresa has spoken there before. We do a speaker day where we take everyone out to the park and pray no one hurts themselves. It's a lot of fun. So, okay. So check that out. Call for papers is open for, where's the thing? I just want to double check. Here it is. Yes, it's open until September 15th. Okay. Yeah, there's a lot of Pratik Patels, so that's why I said /PR Patel. You'd never so Patel is a common last name from people from India. My mom and dad came to the U.S. a long time ago.
What does it mean, though? We have two of them in our team. What does it mean?
Oh, that's a good question, right? It depends on who you ask. But the reason why there's so many Patels is, this is probably better over a beer, but I'll give you the very short version of it, okay? Which is when the British came over and they insisted everyone have a last name. Basically Patel is the name that was taken up by the farmer caste. And as you can imagine, 400 or 500 years ago, most people were farmers back then, right? So there's different last names for people who are business people, or or priests and stuff like that. So, and then for some reason, Pratik is also a very common first name. So don't search for my name. Just use PR Patel and you'll find me pretty quickly. Okay. Anyways, I will shut up now and turn it back over to Jonathan. Thank you for having me.